And it's in right in the middle of South Africa on a high plain. And just outside town is the now Boyden Observatory. Well, it turned out, and I won't give you the history because that's a talk in itself, but Boyden was moved from Arequipa in Peru to Bloemfontein, South Africa, because of the improved seeing and, get this, the improved political situation. And this was in the 1930s when Harlow Shapley was the director of Harvard, and he's the one who moved the observatory lock, stock, and barrel to Bloemfontein. This is an observatory that had a 28-inch refractor, and now it is a planetarium. So I spent many, many days inside this planetarium training the staff. That was my job. But you can see the old wheels of the dome. They actually retained the feel of the old observatory inside the planetarium. And the telescope was long since disused. And it was actually a rusting heap outside somewhere in Bloemfontein. They've now found it and refurbished it and have it on display outside the front of the building. And here are the tubes that were in preparation for that presentation to put them outside the front of the building. Again, this is a whole talk in itself, but this observatory was managed by the University of Michigan for many years. Beautiful telescope, and it was used for imaging Mars. The very first color photograph of Mars was taken with this telescope by a guy called Earl Slipher. And if you know your Mars history or some of your astronomical history, Slipher will be a known name to you. Vesto Slipher worked in Flagstaff Lowell Observatory back in the 1920s and was the one who was creating, getting spectra of galaxies and handed those over to Edwin Hubble, who then discovered the expanding universe with some of that data to help. Earl Slipher was his brother, and he lived well into the 1950s. Here's the Boyden Observatory. This is the library. There's a house over here, which is where I stayed for a week to do my observing. And this roll-off roof observatory houses that famous 13-inch refractor. These trees were planted by direction of Harlow Shapley. They've now grown a lot taller since he was around. And there are many other telescopes around here. Some of you know that after I did my university degree in London, I went to work at the Almar Planetarium, and Almar had a link to Boyden through the Almar-Dunsink Harvard telescope, and that is located on this site. And in fact, well, I'm going to show you a picture in a minute of one of the early directors of Almar Observatory who spent many times down here. And so I felt a connection there as well, because I often heard of Boyden, not only from the Mars book, but from my work at the planetarium. Here is a rather fascinating photograph of an exhibit in the library at Boyden Observatory. And it's using equipment used at the Lamont Hussey Observatory. That's the observatory that has the I'm going to say 28-inch. And it's an amazing thing. This box was sitting in a corner on one of my visits. It says property of Lowell Observatory, and it had a brass tube in it, and nobody really knew what it was until somebody noticed this photograph down here of Earl Slipher with a color camera attached to the 28-inch telescope, and it has a number 1 marked on it, and the same number 1 is marked on the edge of this tube. This is the first color camera to take a photograph of Mars. Unbelievable history. And there it is sitting right there. And you can read a bit more about Mars if you go and dig out this book. It's an absolutely majestic book if you're into Mars, which Earl Slipher published after his expeditions to South Africa to photograph Mars. So this was the first color photograph in 1939. And this is all happening around this Bloemfontein Planetarium that I happen to be lucky enough to get to work at. Another thing is that here's me in the library of the university handling Harvard College Observatory photographic plate of Mars taken in the 1954. These are black and white images taken with that telescope. So you can see I'm on a bit of a Mars kick. Here is the 13-inch Clark refractor, and it's a beautiful telescope. Just to give a bit of scale, here's me trying to focus. It was a brute to focus because it was very hard to turn the focusing wheel. And here's a modern computer over here. I'll show you that in a moment. Here's a picture of Mars rising high in the sky from South Africa early in the evening. Here's just another photograph for scale to say, you know, this is a huge telescope. They've painted it an interesting color orange. And this is what Mars looks like if you're at the business end of the telescope looking up. And I just wanted to capture this because I was sitting here for hours imaging Mars with this view, and I thought, I don't want to forget this view. And so hopefully that kind of, those of you interested in historic telescopes will be just salivating at this moment. And it was a moment in my life that I never thought I would get, and then suddenly realized I had the opportunity, and I just had to do it. And so here's a view of the roll-off roof observatory. Here's the Milky Way going high overhead. Mars literally went straight overhead during the night. So did Jupiter. So I did imaging of Jupiter. And here's me crouched down at the bottom end of the telescope, actually looking at Mars. And then here's a photograph I did of the Milky Way, just rather heavily processed, I'm afraid. That's a bit overdone by my taste now. But there you go. That was my taste in 2018. Out of that Mars book that I showed you, here are some comparison photographs of Mars from 1956 taken in Flagstaff in Arizona with a 24-inch and South Africa with a 28-inch by Schleifer himself, made at Bloemfontein. So this South Africa link was just a big deal for me. Here's Schleifer's visit to the observatory in Boyden Observatory in 1954. Schleifer is on the right. This is a guy called Aidan Fitzgerald, who I got to hear about a lot in Northern Ireland because he was a very famous amateur astronomer in Northern Ireland in the 50s. And next to him is Eric Lindsay, who was the director of the observatory and the first director to really want to build a planetarium on the site of the Armagh Observatory. And he traveled to the US a lot. He knew Harlow Shapley. He knew a lot of people building planetariums in the United States, and he wanted one in Northern Ireland. And he was the one really, the power behind building the planetarium. And of course, Patrick Moore became the first director in 1968. So this was sort of the Armagh link to Boyden. Here is the photograph of Schleifer helping load a plate into the camera. This one is camera number 2. There's also another photograph with a camera number 1. And this is today. This is what we do today. We don't have these large film things. We have these tiny little advanced video cameras that can do very high data rates. I could put a filter wheel on here with a red, green, and blue filter wheel and use this old technology, this old 13-inch refractor for imaging of Mars. Now, old 13-inch telescopes are not perfect for imaging the planets, I might add. Most of the images had blue fringes, but this is my attempt at imaging Mars. It was the first time anybody had used a video camera on this 13-inch telescope. And of course, I spend my trip going to this fantastic perihelic opposition of Mars, and there's a global dust storm. What can you do? So those of you who observed Mars a couple of years ago know all about that. Mars was very dusty. It was a challenge just pulling out this detail. There's the polar hood that is now reappearing on Mars at this opposition. The polar cap here, some clouds. Again, a very strong blue tint to this image. It was very difficult to get rid of because of the optics of the telescope. And I wrote at the time requesting some assistance from Damien Peach, who's aside from being one of the world's best planetary photographers, was assistant director of the Mars section of the BAA. He said, why am I getting all this blue stuff? And he said, yes, that happens with old telescopes. So he's the one who helped me understand that. And then on the right, believe it or not, and I didn't quite know this, but on the right is the first image of Mars through this telescope, taken on June 16th, 1888. This would have been from Arequipa, Peru, at the original Boyden site. So I had a week of just immersed in the history of Mars imaging, and then attempting my own Mars images here. And I just found that whole experience magical from the historical point of view. I then got home, and this was interesting. I got home, and the night that I got home, it was absolutely crystal clear night. The seeing was fantastic. So I got my 14-inch telescope pointed at Mars. This was an infrared image, much, much better than any of the images I got the previous week in South Africa. And then I put a color image together, sent it off to Richard McKim at the BAA, and he said, you have a bit of a dust storm happening in this region here, Solus Lacus, yes. And so I couldn't believe it. I travel all that way, and then I come home and I get a photo of a new dust storm happening on Mars. But anyway, the atmosphere cleared beautifully and so on. I did since complete my Mars, I guess, travels when I attended the AAVSO meeting in Flagstaff, Arizona later that year in November. And I had to go pay homage to the 24-inch, the observatory, the telescope that Percival Lowell built to observe Mars. And I was able to get 10 minutes before the public came in to connect my camera to this telescope and image Mars. My filter wheel didn't work. So all I got was a set of images in the infrared, which was pretty good, I have to admit. But that's kind of my 2018 tour of visiting Mars during a perihelic opposition. So so when I'm 75, in the next perihelic opposition, I'm going to be able to put up my feet on the sofa, glass of my favorite beverage, and go back and look at my 2018 images, right? Anyway, so now onto the real main part of why we're here to talk about imaging. And George, could you remind me how much more time we have left?
We're okay.
Okay, I will, because I've got a lot to go through. I'm going to go through fairly quickly. I imagine some of you have heard talks about planetary imaging from people who are much better at it than I, and there are many links on YouTube for discussing planetary imaging, and I'm going to pull out some of the things I've learned. I've made some big steps this year in planetary imaging, which I have not been able to do previously. And so I'm very pleased with the direction that I'm going. And so we are met with challenges wherever we live, and that's with seeing conditions. This is the ability to see fine detail on a planet. And we live under a very dynamic pool of air that never ever sits still. Certainly not if you're in Kansas, which is where I live, and certainly not in the UK, which is where if we have hurricanes or stormy weather around here, it travels across the Atlantic Ocean and you get to visit it as well. So sorry about sending you that weather, but that's where it goes. What we're looking for is a perfectly smooth laminar flow with no turbulence. And none of us gets that unless we move to locations that observatories have already picked, or we get to travel to beautiful islands like Barbados. I found a fascinating discussion in Sky and Telescope. If you have a historical set of Sky and Telescope magazines, this is from 1971, and you'll see here it says Seeing and Scintillation. And in the same issue is Telescopic Observations of Mars in 1971, and it's written by Gerard de Vaucouleurs, very famous French planetary scientist. But this was written by a guy from JPL, and he describes some of the challenges we have in imaging, and in particular planetary imaging. And remember, this is a large number of years ago. One of the challenges is as the images come in, or as light comes in into our atmosphere, we get a wavefront disruption of the very smooth initial plane wavefront, and it gets scrambled. And sometimes you can have a large distorted wavefront here, and what happens in the with a large telescope is different pieces of this image are in different locations, and you tend to get multiple images across this large aperture, and the entire image is scrambled. With a smaller telescope, what you get is you're capturing almost part of a plane wave as it fluctuates, and you get kind of a very gentle rolling of the image. But if your aperture is too large, you then would start encroaching on these other parts of the distorted wavefront, and it would start scrambling the image. So this is very important to think about. Sometimes you can have a 14-inch telescope in my case, and it would be a great advantage to me to stop that down to about 6 inches if I knew how large the cells were above my head, which of course I don't really. So instead, what I do is I try and favor imaging on nights that are very clear and very steady. I'm going to talk about this a little bit. In this article, he says, at Boyden Observatory at a hilltop near Bloemfontein, South Africa, the seeing is good until the inversion layer rises to the height of the telescope. Then it deteriorates greatly due to turbulent mixing of warm and cool, blah, 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 blah. My point of posting this is 1971, they mentioned Boyden Observatory. I thought, wow, what a wonderful coincidence to my little history that I just told you. Anyway, here's an example of a photograph they show in that article of the sun, the photosphere of the sun, and you can see that part of this image is in focus and the other part is scrambled. This part is scrambled. There's a piece here in focus. And the article talks about if we could develop a system of photography that could capture each of these frames, we could potentially reconstitute a very clean image. This is in 1971. And now, today, folks, we have that technology. We can do it, and the software is free. So we live in a very magical time for planetary imaging. We also live in a time where we have some very great tools for predicting seeing conditions, and Meteor Blue is a website that I use a lot, although I don't always believe it, because sometimes it's not telling me the truth. The problem is this is only updated, I think, twice a day, and in Kansas, things can change by the hour. We can suddenly get a thunderstorm build up, and it really damages the atmosphere. But the key part here is this piece in red. This is the speed of the jet stream above my town, above my telescope. And you see this was Wednesday night this week. You see it was up at 32 meters per second into the evening. It was dropping. And by the early morning, it's down at 10 meters per second, which is very good. Green means pretty good. But half the sky is clouded over. What can you do? So what you do is you try and watch for times that this is very low and you have a clear sky, and that happens to be occurring tonight here. So if any of you want to come over and do some observing, you're very welcome. Oh wait, we can't fly, can we? Never mind. Okay, so the other thing I'm going to talk about, or just mention, is some of the things I've done to really get my telescope fine-tuned to up my game in planetary imaging, because I've done a lot of planetary imaging and got very random results. So I decided to start paying attention to some things, and one of the things I paid attention to is getting the telescope cool in time for observing at night. During the summer here, the temperatures reach 34, typically during the day, 35, sometimes 38. In the observatory, it's 40 to 42, and sometimes above that. I can't even walk in there and breathe. And so for many years, I thought I really should install one of these portable air conditioning units. And this year I took the plunge because I was getting really serious about planetary imaging. And during COVID-19, since my job went by the wayside because of COVID, no museums or planetariums were open, I had a lot of time on my hands. So I'm going to do planetary imaging, and I'm going to really make this happen. So the first day, my wife helped me install the air conditioning unit, and I turned it on, and the first night I went out, for the first time at 9 o'clock in the evening, I saw airy diffraction rings on a star. Never seen that in the evening. I always had to wait till 2 in the morning. So instantly this worked. Instantly this worked. Cooling the telescope to nighttime temperature during the daytime was absolutely wonderful. And it meant I could do a decent job of collimation. So what I do for collimation is I actually take a video capture of a defocused star, so it's slightly out of focus, and I'll capture an image and put it through the process just like I would planetary imaging. I just capture about 20 seconds, and I process it, and here's one of the images. And you probably can't tell, but this black ring is slightly closer to the upper edge here than the lower edge. These two rings here are slightly fatter than there, and this is the corrected one. It's incredibly subtle. And I've learned from talks by Damien Peach and Chris Go and other people, collimation, that final touch of collimation, changing the collimation screw by a 16th of a turn is critical to getting the fine detail. And I've never really spent a lot of time trying to do that. So this time I decided to do it. If my seeing is good, one of those turbulent, gently turbulent days, these are the collimation images I get. If the seeing is all scrambled, this is what I get. And if I see this, I pack up and I go to bed. It's not even worth planetary imaging if the sky looks like this. So what I wanted to do is describe this difference between coherent imaging and chaotic. No amount of software will pull out defined details if your image is just scrambled. It's incoherent images. And the software that I'll talk about later, which uses this thing called wavelets, wavelets allow you to reconstruct an image, but only if pieces of the image are crisp and clear, and it can recognize dark and bright shades and actually stitch them back together. If you don't have that, you're in trouble. So I'm going to try something here. Hopefully this works. I'm going to show you a couple of videos as examples. And you can tell me, George, maybe if this is coming over okay. I don't know what the frame rate is like on the internet.
It's good.
It's good. So here's the red spot. You can see a lot of turbulence drifting from left to right. The whole image is moving, but this is not a bad image. There's some chaotic stuff happening in here, but if you can see these pieces of detail, and every now and then it goes crisp, and those are the things you have to focus on. It's very challenging to focus. Then this is a reasonably good night. This was from August 13th. So I'll show you another example. This is a horrible night. And there are two things happening here. One is the image is almost completely scrambled. I'm getting very, very few moments of very steady seeing. I'll still try an image on this night because I'm crazy. But this is typical of Kansas. And one of the things I've seen, if you're really trying to push yourself in planetary imaging and improve, what you'll see is you'll get these posts from various top planetary images, particularly Chris Go in the Philippines, who says, yeah, this was an image from an average night. His average night is my number 11 on a 1 to 10 scale. Okay? Average is a relative scale, what I've found in planetary imaging. So bear that in mind. I remember years ago, I wrote to Chris and said, you know, what can I do about my imaging? I'm just trying to improve. And he wrote 3 words back to me. That's all he put in an email: location, location, location. He is in an absolute prime location. He has no jet stream. No jet stream. And so every night is crystal clear for him, or very steady for him. He gets a laminar flow. It's absolutely a perfect location for planetary imaging, which is why part of the reason he can get so good at it, he can really fine tune things. But for most of us, we can't afford to move, and we're stuck under the air that we live under. And so what can you do? I'll show a final little piece, and this is a really good one. This video was on August 1st of this year. I think it's a rather large video, so it'll take a moment to load. Let's see if it'll open up here. I don't want to double click it again because it might freeze my computer and then we're in deep trouble. Let me just change screen and then go back. And then try again. Yeah, I don't think that's going to work, so I'll just move on. This is a video where the image is just gently rolling. And that's a very rare night here. And they're the nights I stay up all night just recording video. Here it goes. And you can see the red spot is here on the left. There's some dramatic detail in the north temperate zone, north equatorial belt here. And you may also notice one other thing that I have to contend with. You notice how that image is rocking? I have a train going by half a mile away. And it just rocks the image. And I have to stop recording while the crazy train goes by. And trains in the United States are about a mile long, so it takes a few minutes for it to go by. But anyway, this is a very, very good night for imaging. You can really see gradually some fine detail, but it's very typical. You can actually see in the wake of the red spot, sometimes you see a little white spot right there. If you can see that, you're in really good shape for imaging. If you can't see that, you probably should just go to bed. Okay, so that's some examples. Going back to my imaging again, you have to record a lot. Here is July 25th, a compilation of 3 sets of RGB images into a color image, one at 5:14 down to 5:42 a.m. This is its universal time. And hopefully with the resolution of your screens, you can see this is actually a pretty good image. And this is pretty good. And oh, wait, that's the one. My goodness, what an amazing image. And then it goes fuzzy again. And it's only, I can tell you, it's only in the last 2 months I've started really recognizing that this is what's happening. And this is a very rare image for me. It's probably my best, it is my best shot of Jupiter this year. But what I wanted to illustrate was what happens on either side. They're still good, but they're not crisp, crisp, crisp. And so this is what I call my Jupiter Nirvana moment. I kind of laugh at myself. I say, yeah, I'm aiming for Jupiter Nirvana. I want to get a picture like Damien Peach gets with a 1 meter Chile scope, right? I want that absolute crisp, and it rarely, rarely, rarely happens. But when it does, you're really happy. I wanted to show you just a little bit and explain that I use color filters for imaging. This is a set of color images with RGB and IR back in 2018 of Mars, and then you reconstitute, well, this one is reconstituting 3 of these into a color image. So the other thing I'll mention, and I think it will be, okay, the other thing I'll mention about color filters is you've got to get good color filters, and I found that out this year as well. I had purchased my ZWO camera. It was a 178 monochrome camera, and I purchased the relatively cheap set of color filters with it, RGB. The RGB cutoff between the red and the green had overlap. And I thought, well, I can't really afford any higher quality filters. But that wasn't until the the US government decided to give everybody a stimulus check. And so I went off and used part of that and bought decent color filters. So I bought a BARDA set of RGB filters, and they really create quite a bit of a difference in the imaging as well. So you do get what you pay for, and you'll get the results that you pay for. But getting a very clean, crisp cutoff for the waveband pass band in each filter is very important, making sure they don't overlap in planetary imaging. I'm going to skip through some of this because I know there's a lot I want to really mention, and well, we'll see how far we get. This is what fire capture looks like when I'm actually sitting at the computer. Here's a very fuzzy image of Mars. It's just a shot off my cell phone. It's not supposed to be anything special. You can see you can hardly read the image, the stuff here. And what we're playing with in imaging is whatever the brightness of the image is, we want to get a histogram, which is marked here. If I'm doing red, green, and blue images, I want the red, green, and blue histogram to hit about the same point. And I found around 70 to 75% is my sweet spot. And you have to determine that for yourself just by practice. And the peak of this histogram is dependent on the gain, how much you're amplifying the signal, and your exposure time. And your exposure time governs the number of frames per second. So here the number of frames per second is 75, which is quite low. If I want to get a higher frames per second, I have to lower the exposure time, which dims the image. So I have to boost the gain, which increases the noise. That's the game that you play constantly through the night. You want to get as high a frame rate as you can at an average, at a medium gain, not too high, and as short an exposure as you can. And I constantly play that game and try and find the sweet spot. And the sweet spot is different for every person's telescope and imaging situation and what the atmosphere is doing. So it is a learning experience, and I still feel like I'm at the beginning of that curve, but I've come a long way. But it does take practice, 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 practice. Take lots and lots of images. Oh, this one's clear because I captured it off. So here's a much clearer explanation. This is not true. I never set the gain to 3,600. This is just a default setting. But here are my 3 filters. And so this is a comment about focusing. Focusing is enormously difficult with an image that is going in and out of focus. It's very, very challenging. And so I have a robotic focuser on the telescope. Absolutely, for really critical imaging, I find this absolutely critical. I have a Celestron telescope, and if you turn that focusing knob, it's tilting the mirror. Even slightly, it's going to tilt the mirror. So you need a separate independent focuser, lock the mirror down, focus with some other device. And this year, and it was only in July, I finally got around to putting this together, but I've had the focuser for a long time. It's ridiculous that I took this long to get this working, but that's me just being critical of myself. And so what I do is I set the infrared, infrared's easiest to focus on, and I set the focal position, which is part of the panel down here. I can focus very precisely with certain steps. And then the red, green, and blue are simply offset from that by about 30 or 40 steps each. So I can focus this one and then quite quickly set these numbers. And in experience, you can guess those quite quickly. Another thing, and again, there are videos of people who go through fire capture and they go through AutoStack and they go through Registacks, which I'll just briefly mention here, but I want to give you just a few hints. WinJupos is a software that helps you align your images later and stack them. And you want to have WinJupos naming checked. So your name of each file actually has the date and time embedded in it. You need that set. And then this is, again, just looking, oh, and the other thing is that you don't have to use the maximum field of view of your camera. You can just grab, like you would do a crop in Photoshop, you can grab a square around your image and record just that section, and that increases your frame rate. So that's a very critical step to do. Here I'm getting up to 104 frames a second, which is great in the infrared for Mars. AutoStack, this is software. I'm going to try and demonstrate this to you briefly. But this is software that stacks all of your frames. So you might, here I've got, I think, 16,000 frames of Mars. I import it, I click Analyze, it analyzes it, it gives me a graph here. The green shows me the quality, which is disastrous for 90% of the frames I have, and I have something like 5 to 10% good quality, which are above this 50% line. This jagged gray bar is simply showing where each frame is and its relative quality. But what AutoStack does is it creates a stack of those images where the best quality are at the front and all the rubbish is at the back end. So you get rid of those and you only stack the images that you want. The other thing is, and this is something else I learned this year. Oh, well, I mentioned one more thing. In the settings, once you've loaded a video, you can go to stack options and you can say automatically open in Registacks for wavelet editing. This is a very helpful step if you're doing hundreds of videos. This will help you skip through it a little faster. And the other thing that I didn't know, and this is one of those little details that they don't tell you, is when you open, I used to open each video and then stack it and then go do the next one. You can open multiple videos all in one go and leave this stacking while you go and do something fun instead of watching this going. So I didn't know that you can actually load multiple videos in one go. So what I tend to do is I load all of my reds together and I stack those. I load all the greens together, stack those. Some people just load their entire night if they're getting good quality images, and they just load the entire thing. What you do here is you set the number of alignment points, and this is a critical step. This is a critical step that I never got right initially, and I learned this year from a friend of mine, Clyde Foster in South Africa, who is one of the top planetary imagers. You need to make these quite large. You want, for Mars, you want something like between 10 and 30 image squares. What each of these squares is doing is looking for a dark edge that it can find in every frame and then stitch the frame back together. And if you make these too small, like here I've got 53 of them, these squares are too small. I had the erroneous idea that if you're going for fine detail, you need to make these small, and that's wrong. What you need is a coherent image where the squares are large enough that it can pick the coherent pieces of the image and stitch it back together. It's a very important concept. Okay, Registacks. This is the magic. This has a set of things called wavelets. It's essentially magic. You go from an image like this, which comes out of AutoStack, and you tweak these bars, typically number 2 and 3. Like I've changed number 2 and 3, and they sharpen the image. So you go from there to there. This is an image taken on September 3rd. So what was that, last night? Well, I should remember, right? Because I was up. It's not this morning, but the previous morning. And so that's what you can get. It's really stunning. And I'm not going to spend too much detail on Registacks. There's too much to go into. I will mention cameras as well. This was another little step I made this year, improving the camera. I've imaged for a number of years with a 178mm with the idea that this is a large chip. It's 3,000 by 2,000 pixels. It's a huge chip. Why a huge chip? So I can find the planet. it's really hard to find the planet in this tiny imaging chip. So you got to have your telescope really well tuned to pointing very accurately. But I decided to go to a smaller chip because everybody was using an ASI 290 mm. This is a monochrome. There is a color version of this if you want to do straight color imaging and not mess with your color filters. But for that, you need an atmospheric dispersion corrector to help, because red, green, and blue images focus at different places on the image plane. So you have to shift the red, green, and blue images to make a color image. It's a bit complicated. But here's the reason why I went for this 290 camera. Quantum efficiency. This is the efficiency of the imaging chip to light. And what does quantum efficiency do? It changes your exposure time. If you have higher quantum efficiency, more light detected, you get a higher frame rate and less gain with a better quantum efficiency. This is why this graph is important. On the left is the 178 that I used for years. And notice this goes from 0 to 90%. This one goes from 0 to 100%. Very important difference. And you can't tell, you've got to read the details when you look at the specs on your camera. This one at 550 is 75% quantum efficiency. At 550 here, 95%. 20% more light I'm collecting. That's huge. That's huge. If I collect 20% more light with this camera, I can shorten my exposure time and get a much higher frame rate at 500 nanometers. And at 600, it peaks at 100%. It's detecting everything. And in the infrared, down here at 800, I'm still detecting 65%. At 800 here, I'm at 20%. My infrared camera with a 290 is 3 times more sensitive than this one. No wonder I couldn't get decent planetary images with a 178. I mean, I was getting okay ones, but my frame rate was down at 50 or 60 frames per second. With this one, I'm at 150 frames per second. And with that atmosphere moving around over my head, 150 frames per second freezes that motion. At 50 frames per second, they're blurred. So you gotta look at your camera and look at what the sensitivity is and get the highest sensitivity you can for your filter set. Very important step. There's a new camera out. It's an ASI 462 or a QHY 462. Both companies are doing it. It's currently a one-shot color camera. Soon they'll come out with a black and white one. Nobody knows when yet. But this is the quantum efficiency. Now, it may look a little bit crazy because it's a single color camera. The black and white will be more sensitive. But even in the blue, it's nearly 70% efficient. In the green, it's 85. And in the red, it's above 90. And in the infrared, the red, green, and blue is identical in the infrared. So you have essentially a monochrome infrared camera as well as a color camera. So people are raving about this camera. I'm not buying it yet because I just bought the other one. So I have to enjoy that, right? Enjoy what you got. Here's my setup. I know cable management is a disaster area. It's actually not as bad as it used to be. I have cables tied up here, and there's a little cable management going on here. But here's the filter wheel, here's the camera, and I have a Barlow lens. I have a finder, and this is a horrible finder because it always moves, so I never know what I'm doing. But here's an auto guider, and what I do now, I did not used to do this, but what I'm doing now is I have that auto guider with a crossbar on it, and I get the planet right in the middle, and then I know it's on my camera chip. So you have to have this very finely aligned to your telescope, which is something I only did in the past month. I have a 2x PowerMate Barlow. I'm going to talk about Barlows. Actually, I'm going to talk about Barlows now. This was something else that tripped me up. I had a 2x Big Barlow. That's this orange, purple bar here. A 2x Big Barlow. And I was getting very low frame rates, and I couldn't understand why, because at 2 times I should be able to get. So I chatted a lot with my friend in South Africa, Clyde Foster, and we had a long discussion about this, and then we realized that a Barlow is not what you think it is. It's only a 2 times Barlow if you are, if your focal position is 0 millimeters away, well, the lens is 0 millimeters away from the focal position of your Barlow. As that increases, the magnification increases. And I was something like 80 to 90 millimeters away from the Barlow because I had a filter wheel and I had the camera. So I'm too far back for this thing. So I'm nearly 3 times magnification. So my image brightness was cut 30% and my frame rate was cut 30%. So I'm not imaging at a high enough rate with this Barlow. Go to a power mate. A 2 times power mate, it does not matter what distance you are away from, it is still a 2 times power mate. This was such a revelation to me, and in retrospect I go, well, I should know that. I did optics at university, you know, but must have missed that class, right? But the power mates from Teleview, the 2 times, and look, even the 2.5 times Barlow, that decreases in magnification as you get further away. So that's a very critical part. And I now have the 2 times power mate, and I can get my high frame rates without this crazy magnification going on. Okay, so that's some of the technical things that I do. I'm now going to give you a very brief look at some images and things that have happened in the past 2 months. I think, and I want to emphasize the importance of amateur imaging of planets. My friend in South Africa I've been working with or chatting to for a couple of years, on and off, and now he's helping me learn some of the fine details. We have a great time chatting. About a month and a half ago, he was imaging Jupiter with a methane filter and noticed that next to the red spot, now there was a bright spot that was not there a few hours earlier. And he was imaging Jupiter, and this was for the BAA group. He's a member of the BAA. He was imaging because the Juno spacecraft was due to fly over this region 2 days later. So this was the projected track, and the BAA and other ALPO and other planetary groups try and image the track and send those images to NASA so that they can determine you know, what's coming up. Well, Clyde saw this new spot and instantly sent it off to John Rogers, and it was sent over to NASA, and they got very excited because this spot was in their frame of their imaging camera 2 days later. It's not often an amateur can discover a spot and 2 days later NASA repoints its camera and makes sure it gets a photograph of your spot. So this became very famous. It's called Clyde Spot, and here's the Juno image next to the red spot. This is the image. It was all over the news in early July, and this is a detailed image of Clyde Spot right there, just 2 days after it erupted or emerged. Really a remarkable instance of an amateur and pro-am collaboration. And you probably, some of you will have heard of that story, but if not, I wanted to convey it. Another spot, outbreak on Jupiter. So this one came in an email. It came on a Tuesday morning, and it came into my email as well. Exciting new outbreak discovered by Miyazaki in Japan. He imaged a very new bright spot of this region in the North Temperate Belt. And this turned out to be the precursor to a really big outbreak in the whole Northern Temperate Belt. And, but here was the funny thing. I looked at this image because I'd just done my processing of Jupiter. I looked at this image and I said, wait, his central meridian measurements are the same as mine from last night. I was imaging Jupiter exactly 1 rotation before his image in Japan. I'm in the US, so I'm far enough east to do that. And here's my set of images. You don't have all the times, but in this one at 3:14, there's nothing. And in this one at 3:41, I don't know whether you can see it, but there's a white spot right there. Between 3:14 and 3:41, that white spot became visible. Now, it was probably visible here, but I just couldn't get it on the edge. So it turned out all of a sudden I had a pre-discovery image of this thing, and I was so excited. One of the things I love about imaging is you never know, you might capture something important. And I've told myself that for literally 50 years or more. And this is the first time it's really happened. So I sent this immediately off to John Rogers, and he said, looks like you got the first detection, but there's another guy imaging as well. He had a bigger telescope called Damien Peach. You may know of him. And he was using a 1-meter telescope. So this is his shot, and it's at 3:47. Mine was at 3:41, right there. Same position, same location. Unbelievable. So that's very exciting. And now we're imaging imaging Jupiter as often as we can to try and get fine detail. This thing has really erupted, and it has a wake behind it. If you're into imaging Jupiter, now's the time to get into it, because there's a lot going on. Okay, so now I'm going to wrap up in a few minutes, George, if that's all right. And just show you some of my other images. Here's some of my improvement. It's both improvement of processing and improvement of atmospheric conditions. This is a photo I took on July 7th and then compiled an image. What I was repeatedly doing was using Registax wavelets and pushing them too far, just making it too contrasty. And it's very tempting to do that. I've spent years doing it. And this year, I've learned to ease back on that and do a softer wavelet processing, and this is the result. Much nicer image, much more pleasing image for color balance. It's a more realistic image. This was August 1. So this is 1 month, literally 1 month of imaging and trying and testing and trying to improve. So this is one of my by far better images to date. Mars. Mars is getting really, really good. Yes, it's up late. It's about 3 a.m., 4 a.m. But this is the time to be looking at Mars. It's already 18 arc minutes across. This image was taken in July 25th. Pretty good, quite a large south polar cap, a little notch in it there. Here's the Sinus Meridiani and Solus and the Sinus Sebaeus here. Get my nomenclature right. But this was July 25th, but August 25th, a month later, not only is Mars bigger, but I'm getting better. I've really focused on trying to fine tune, and it's a combination of frame rate, gain, using the right filter set, and the lucky part is getting a good night. And that's in the lap of the gods, right? So this is certainly one of my far better images. You notice the South Polar cap has shrunk. And this is Solus Lacus. Yeah, Solus Lacus here. And the Mariner Valley is actually in here. Some pretty amazing things going on. And I'm seeing stuff on Mars I've never imaged before. And I'm using the same telescope. But I'm using a telescope that's pre-cooled. I'm down at nighttime temperature before I open. And it still takes half an hour to stabilize, but it's really good. This is my last slide. There are tons and tons of guides to imaging. One of my favorites recently I just watched was Damien posted a free video on his Patreon site. A lot of his stuff, you pay a small fee every month to watch, but he posted a free one on best practices. My favorite line from his, and it's one that, I started learning myself, and then he said it, and it underwrote everything that I've been trying to do. You need to spend more time to get good images. You need to spend more time setting your image up before you press record. If you think you can do it all in software, it's not going to happen. Software can only get out the details that are in the original image. So I spend a lot of time focusing, making sure I'm collimated. And in fact, sometimes what I've been doing with Mars, because it's hard to tell if it's in focus, I'll record a 10-second clip in each filter and change the focus position, process it through AutoStack and Registacks, and then save each one at a different focus position, then bring up those 3 images and scan between them really quick and see which one is really sharp. And that's helped my imaging a lot. Gradually, I'll get more experience and be able to do it by eye. But Chris Go has done a 2-hour special on the Woodland Hills and Telescopes YouTube channel. And then look out also for Agapios Elia. He did a 2-part series on YouTube on the Astro Imaging channel. Really an outstanding set of details. And just to underline what Chris Go said, it's location, location, location. My observatory is kind of aligned north-south. And if I look due south when the planets are high up, I get pretty good images. If I look to the southeast or southwest, I'm imaging over neighbors' houses. The seeing is horrible. So sometimes it's local turbulence from heat or whatever that can affect your imaging. Well, I'm going to stop there. Maybe there's some questions. I'll hand it back to George, and I appreciate you letting me go on quite long. Hopefully, I've managed to inspire some people to go out and do some planetary imaging. Can't hear you, George. Oh, I need to stop sharing.
He's gone to sleep, I think.
There we go.
Okay. Well, firstly, thanks very much for an absolutely amazing talk. Also the amusing bit at the beginning, I think, as well. I guess if we can show our appreciation in the usual way or electronically. Oh, gosh. I didn't appreciate it, but my software has been updated and there's a lot more graphics with it. What I propose we can do, we can take some questions now. We'll then have a short break, come back. Mark can do his presentation, thanks. And then I think we just open it up and let people talk about a wide range of stuff. So maybe if you've got questions about imaging, now would be a good time, but don't feel too worried about not getting a chance to ask Martin, because we'll get that later on. And I was going to use chairman's privilege and ask some questions, but I won't. So, does anyone, if you can do it electronically, because I've got to look over a couple of screens, then I can see if anyone wants to ask a question or not. I think you've managed to explain it so well, Martin. They're all a bit, oh.
Or frighten everybody going, yeah, I'm not doing that.
Chris H.
Hi, Martin. That was a fantastic talk. Thank you very much. The question is, you did mention using a dispersion compensator, which is needed with a color camera. Have you ever done that? Have you tried using one with color filters? Does that help at all?
Yes, so I have used the ADC unit for color imaging. So if you have a color camera, that's the way to go. I recommend watching Agapios Elias' video on how to use it correctly, because I was using it incorrectly. And so that was a revelation.
They can be tricky things, I know.
They're tricky. There's a certain, you can either put it in with the arms to the left or the arms to the right, and it turns out they and I had them to the right. But anyway, watch that video. they work really well for color cameras for the reason that I indicated is the red, green, and blue image is recorded differently in a color camera. Well, the atmosphere shifts the image, and the color camera just captures everything in one go, and you've got to shift them back. It's a prism effect, and essentially the ADC is a reverse prism to shift everything back, as you know. Now, what you're using on a color camera is there's a Bayer array of filters, as I'm sure most of you know, with a red, and 2 greens, and a blue. So each color pixel is actually a 4x4 array. And with a black and white camera, you're using the full resolution of all of the pixels. And so black and white cameras with color filters will always produce slightly better images, but you've got to go through a lot of processing legwork to get the image. And you may not want to do that. And quite frankly, if I was starting out now and I hadn't got a camera, I would go out and buy that new camera, which is a color camera. Put that on there, you will get outstanding results. And it's not a very expensive camera. I mean, I don't know what they cost in the UK, but for what you're getting, it's a long way ahead of the other cameras. I'm going to post in the chat, by the way, if anybody's watching the chat, I'm going to post those video links so that they're recorded. There's Damien's video link, and I'll put the others in there as well, so you can just copy those.
Got a question from Steve K.
Hi, Martin. Good to see you. Excellent talk.
Thank you so much.
St. Bart's was a long, long time ago.
Gosh. Yes, it was. And I actually did a visit, it was many years ago now, but they'd sold it.
I know. Yes, I walked down there a few weeks ago.
And I heard there was an old boy who bought Baz's old office as a condominium or an apartment or something.
Okay. Well, yeah. Your last comment sort of answered the question, because I've got monochrome cameras, but I'm fundamentally a lazy person, so I've only ever used them for monochrome imaging. So all you do is RGB. I mean, do you use color cameras at all, or now the new color cameras are coming out, the better color cameras, you think you'll transition to color imaging, or you'll still do RGB?
I have that battle in my head because when I saw the color camera, I mean, Chris Go has reviewed the new QHY 462 camera, and it's spectacular. And I thought, gee, I've just bought this black and white one. What do I do? And then he did make the comment that that he will still be doing monochrome imaging because it is higher quality. I mean, part of it is you have to enjoy the experience of creating those images and trying to get better. If you don't have a lot of time, and I don't know what I would do if I end up going back to work sometime, because I spend a lot of the day processing video, and not every day, but it's challenging. And sometimes I think, gosh, with a single color camera, I could get a color image every 10 minutes if I wanted to, and it would be very easy to do. So it is an easy way to go. And if you want, you know, quick color imaging, it is definitely the way to go, and you will get very good results.
I really enjoyed the historic stuff that you started off with. And I don't know if you can see this, but I picked this up at the Lick Observatory.
Yes, I have
published in 1964. And the thing that astonished me was, you know, these are the best planetary images then, and when you compare them to what amateurs are doing now, it just shows you what the technology has done for us.
So that's part of, and you'll appreciate this, Steve. So it's part of, I almost have to pinch myself every video capture I do. Every video capture, because I grew up like you in the 70s, and they were the best images of Mars, for example. And now in 30 seconds, I can outstrip every major observatory prior to the 1990s.
Yeah.
Instantly. And it's the technology. And I think what was surprising to me was to go back and find that Sky and Telescope article in 1971 that actually outlined the technology that they would need in order to capture images like we do today. But they were too far ahead of their time.
Yeah.
They just couldn't do it. Yeah, it's amazing. I even when I get I have lots of images that I just don't post on Facebook because I don't think they're very good, but they're still 10 times better than anything I got a few years ago. And I just pinch myself each time. Somebody asked me, I think it was my sister asked me, she said, haven't you photographed everything by now? and I said, well, there's new technology and there's new cameras and there's new discoveries. And then I recognized to myself, this is a pastime. And part of the benefit of a pastime is you enjoy doing what you're doing. You're not after the final result. You're after the spending time under the sky imaging. And that in itself is enjoyable. And so, yeah, just keep doing it.
Yeah.
Yeah, if anyone's interested, the camera I think is £290. So not a huge.
Not bad.
Yeah, it's a pretty good deal. I know here it's $290, and there's not much difference between the pound and the dollar anymore.
No. Well, what I'm going to propose now is if we take what I'll call a small comfort and time to top the old cup up as well, and if we can get back, is everyone okay with 9:05? And then we can ask Mark H to do his talk, and then we can just open it up and maybe just have a good chat amongst friends with Martin. Right, good, no objections. I'm going to leave the program running, so if you don't go off, you can talk to each other and do whatever, but I'm getting a few thumbs up. So, okay, if we can sort of reconvene formally, as it were, at 9:05, that'll be great.
I'm just going to sit here if anybody wants to chat.
Hi, Martin.
Hi. Hi, Pauline.
Pauline.
Yeah, it's great to see you, both of you.
How are you?
Doing pretty good. I enjoy following you on Facebook and seeing.
Oh, excellent.
Yeah.
I'm desperately trying to find a picture.
Oh dear.
From September last year, you know, when we went to Armagh Planetarium.
Oh yeah.
And you were saying something about some tapes that you had. I'm desperately trying to find on Facebook the. Can you remember what it was?
Yeah, I do remember because they're right here. I have in front of me, for example, BAA Winchester 1974.
Oh wow.
1970,
Oh my God.
1975. I have Arthur Curtis's last presentation.
Alfred
Curtis.
Yeah.
I'm thinking of Arthur Clarke. And I think what I sent to you was I started transposing them into digital, and I said, because these are too good to leave. And I was given that I didn't record them. It was Don Topley who recorded them. Those of you who went to
my God.
they remember Don sat in the front row and was constantly changing his cassette tapes. And when he died, his wife, his widow, gave me these tapes, and I said, we can't lose those. And I've often wondered what to do with them. And now I've got some of them transposed as digital, and now that it's broadcast publicly, we're going to have to do. I'm going to have to not be lazy anymore and do something with it, right?
Oh yes, please, Martin. That'd be brilliant.
But-
Alan would be so pleased.
Oh, I just imagine Alan must be probably couldn't believe that they existed.
No, no.
I mean there are.
There's nothing on them he wouldn't like to see, is there?
No, I don't think so. But I mean, and there's 1977, 81, 82.
Oh my God.
There's Hedley Robinson. There's Commander Hatfield.
Listening to this, Alan.
There's Patrick. I mean, all the people that we grew up with and learning from are on these tapes.
Indeed. Now, Martin's just telling us about all the tapes he's got. Here he is.
Hello. So I'll do the same for you. Can you read that? It says 19.
Winchester, 1973.
So I have Don Topley. Do you remember him? He used to sit in the front row and record everything.
Yes, indeed. Yeah.
And his widow gave me all the cassette tapes.
Ah, amazing.
And I thought one of these days I must do something with them. So I think it was 2 or 3 years ago I started on a project of transposing them into digital. And then I think I sent Pauline a note, and then I got lazy and I haven't done anything with them. But I know they're sitting on this computer that I'm using, and I need to. Yeah, they're in digital format, unedited, so there's lots of gaps and stuff. And I thought, well, what I should do is edit them, but I frankly don't have time to go through. But there's probably 30 tapes here. Hedley Robinson, Commander Hatfield, Alfred Curtis's last goodbye, which we didn't know it was at the time, but
yeah, that's amazing.
It's I mean, as a historical thing, I always thought I've always just kept them because they were too good not to do something with. And
have you got the only copies then, Martin?
I believe so.
Yeah.
Oh my God! I mean, they're historically valuable.
It's amazing.
Amazing how they ended up in America.
Yes, how did they?
Well, it's just
So we're going to need.
I never let
we're
any.
going to need some way.
Oh, he's going to digitalise them.
Yeah, we're going to need some ways to get them from you to us to the BAA or.
So I think the way to do it is, I mean, what I can do, I don't even know. I can look up and see what I have on here. BAA, let's see. I'm not sure where they are. Maybe they're in my music.
Good a place as any.
Gosh, I have to go look for them. But I know I did something like 10 of the talks. And so they're available now as digital. And I think all we need is like a Google Drive or something. I can drop them on there.
Yeah,
Well,
yeah.
Martin Mobley puts most of the stuff on YouTube, so you could go onto YouTube.
Okay, we're
What do
on.
I do? Share screen? No, that's not right. No, hang on.
So we're back in action now then.
What do I do? Share screen?
Yeah, just click the green arrow that says share screen at the bottom.
Then I go on the screen one. Share.
That's it.
That's it. We're nearly there.
Hey, we're hot to trot.
Are you going to mute everybody, George?
Yeah, I'll do that. You'll have to unmute yourself, Mark. Bottom left, Mark.
Hooray! I'm there now. I should be.
Yeah, you're hot to
Okay.
trot.
Okay, let's. Now, what are you seeing, the presenter screen or the main screen? Hang on.
We're seeing the main screen.
Are you still seeing the main screen?
No, we've got the presenter screen now.
Okay, then hang on a minute. Right then. Okay. Thanks, George. This is going to be a short presentation. I'll keep to time if I possibly can, covering the astrophotography I've managed to do since March this year. Before that, I'll give a quick overview of the observatory and the equipment I've been using in the past and the observatory as it is now. First slide. Come on, there we go. The observatory is a GRP pulsar dome I bought back in 2015. Now, my back garden's only very small, and the dome would clearly dominate the back garden in such a small space. So I specified the light green colour, so it wouldn't be so intrusive to me or the neighbours. It was all finally up and running in about April 2016, so I've been using it now for about 4.5 years. It's a good site with an open east aspect. I'm lucky to have a fairly good view from the northeast, which is behind the observatory to the right of to the left of the picture there, right way round to the south. And that's probably the optimal position for astrophotography, because you sort of catch things low and they get higher as you go through the night. I started out doing visual work on this, but had to give up because of the light pollution. Photography is the way forward. Initially, the observatory was fitted out with an 8-inch Rishi Chrétien telescope and an 80mm Explorer, which I could use side by side on this mount over here. But there are great problems in doing this, since anything you add to one side, either the 80mm or the main scope, upsets the balance. And I had to construct this central device here to control the balance between the two scopes very carefully. Back in 2018, when John Napper updated his scope, I was fortunate enough to get his C11, which you see in the picture on the right, I hope. So let's move on to that. Here we go, which is a lovely, lovely thing. The dome has got a pod built into it. You can see it here on the left-hand side. It houses a PC. I can control all the equipment from inside the dome, but usually I do that from in the house, where it's lovely and warm. Marty was talking there about the free software. Well, I did a quick look up today, and it's surprising, 14 out of the 16 applications I use on various times to run the telescope control and data acquisition are all free. And the 2 that aren't was supplied, the software was supplied with the camera and the focuser. So that's amazing. That's not fully automated. I still have to open and close the dome manually. The off-axis guider on the right here is an absolute boom. Wouldn't be without that now. That's a wonderful thing. I still have a backup device. The image on the left here is the conventional sort of arrangement that Martin was showing, but I haven't had to use that yet. If you've got a sensitive camera on the off-axis guider, you can pick up stars pretty much all the time. The off-axis guider works by pinching a piece of the light cone that goes to the main camera that wouldn't otherwise be used, and a piece of software called PHD2 keeps a track of a star and drives them out accordingly. Now, I lied. Lockdown this year coincided with a period of good weather, unusually, and I was able to do some work on what I termed interesting galaxies. If we look at the graph here, you can see this histogram. You can see how the 2020 season was much better than we had the year before. Now, I don't usually do galaxies, but I thought I'd give them a go this year. There's nothing else to photograph that time of the year. As there are fewer planetaries around, I ended up doing galaxies. But I thought I'd try and find some interesting ones at least. Yeah. Right, this is a close alignment of 2 galaxies in Coma Berenices. These are gravitationally bound pair. Their distance to these is about 50 million light years away, so there's 2 million light years between them. They are the same type of galaxy. The bottom one, 4302, is about 60% the size of the Milky Way, and the other one's even smaller. But they were discovered by Herschel in 1784, and he seems to get to all of these before I do. The lower one, the edge-on one, sorry, that's about. So the distance between these is about the same as the distance between our own Milky Way and the Andromeda Galaxy. So the close alignment thing, they're not quite as close as they look, but they are gravitationally bound. What I was going to say about that one. Let's move on. So I'm not looking at my vision. Now these were great. These are obviously an interacting pair from the ARC catalogue of peculiar galaxies, ARC 271 in Virgo. Again, Herschel had seen these. They're about 120 million light years away, and these are fairly small objects in the field of view. The field of view here is only about 16 arc minutes across. So if this were a photograph of M51, it could just about fill the field of view. Now, these were difficult things to do. They attain an elevation of only about 30 degrees from my garden. Now, I normally wouldn't even start to image things unless they're about 40 degrees up and getting higher. So these were difficult to actually pick out in the south. I had to pick them up when they're 20 degrees, up to 30, and lose them again before they fell below the wall of the observatory. On one of the nights of photographing this object, John Napper was also doing the same thing. And he spoke to me the following day, I think, asking me if I'd picked up an asteroid in this in my pictures. And we tracked it down to an asteroid called JH3 2007, which was discovered with Cape Peak Observatory. When he pointed out exactly where to look on my frames, I could spot the thing. And the asteroid was magnitude 18.9. It's only about 3 kilometers across, apparently. I thought that was quite good going. Now, these were difficult for me to spot, so Herschel did well if he spotted these 235 years before me. This is the Splinter Galaxy in Draco. I had started to photograph the nearby Spindle Galaxy, which looks very, very similar, but switched to this one as it looked more interesting. It's about 50 million light years away, and according to the professionals, it's a bit of an oddball. It's isolated in space, and it contains very few massive stars. So supernovae are rare in this thing. It was the last one seen in about 1940. It's had an interesting encounter in the past because in 2006, it was a photograph was taken that shows a wide loop of stars that wrap around this galaxy, where it had swallowed up in the past one of its dwarf galaxies. Imagine the Magellanic Cloud being broken up by the Milky Way. But recently, the two loops that exist around this thing, when they've tried to rephotograph them using a thing called the Dragonfly Array, they can only spot the one loop. So it's a bit of a mystery. If you go onto Google and type the Splinter Galaxy Dragonfly Array, there's a whole interesting story there. Right, now, Steve and I are constantly enthusing us to photograph the ISS, and I've never thought I could get the thing in view as it zips past so quickly. But now it seems the ISS is coming to find me. I was imaging the Tulip Nebula one night in Hydroid Alpha and surprised to see what I thought was an aircraft trail, but this was the beginning of lockdown. And there was a big drop off in air traffic due to the pandemic. I spoke to John about this later that same day, and he suggested I look up the Heavens Above site to see if it was the ISS, and sure enough it was. It passed through, if you can see here on the picture on the left, right through Cygnus, right through where I was photographing. And it would have gone through the field of view in about a tenth of a second or less. So in my 3-minute exposure, they zip through and spoil one of my frames. Let's move on to the next. And this is what I was aiming for. It's the Tulip Nebula in Cygnus. It's about 5,000–6,000 light years away. So this is what the image should have looked like if you avoid pandemic dodging space joyriders getting in the way. Now this was a disappointing bicolour image given that it was about 12 hours of exposure. It really should have produced a better result than that, but it's very faint in the blue. I've also got uncertain about the quality of my oxygen 3 filter, which I'm using these days for other reasons. Now, my favourite subjects are planetary nebula, and this is, as well as that sort of dark cloud molecular stuff, which I'll show you later. The Oyster Nebula in Camelopardalis, again discovered by Herschel. He clearly got more observing in than I do. It's a lovely little object showing lots of fine structure. It's difficult, as usual, to control the size of the star. When you're enhancing the detail in the nebula, you tend to make the stars very big, and that's a constant problem in this imaging. Now, this photograph wasn't actually taken during lockdown, but I keep a close record of all the pictures I've taken and found that I'd catalogued this one incorrectly. When I found I put the right number on it, I realised I had enough to make a photograph. So that was from actually taken this time last year. It's essential to keep an accurate log of the pictures you've taken, because weeks, months, even years can pass before you get a clear night again. Now this is a truly wonderful thing, I think, in Cepheus. It's the Iris Nebula, and you normally see this thing taken pictures through a short focus refractor or a camera lens. It's about a couple of light years across, so you're looking at something like half the distance from us to Alpha Centauri, the scale of the picture there. The C11 normally has a drawback in that it's such a long focal length, but here you're really looking into the heart of the thing. And it's one of those subjects, I think, that really has a 3D effect to it. It's as though you can see the thing in depth. Again, it's very difficult to enhance the nebulosity here, which did require some pushing without overreaching the stars. There are clever bits of things you can do in Photoshop to offset the problems you'll get with the star images, but, which I usually have to invoke on all of these pictures. Now, one of my all-time favourite subjects, the Bubble Nebula in Cassiopeia. Here, a sphere of gas has formed around a massive hot central star, and the envelope is coming up against a wall of interstellar gas, which you can see on the right-hand side of the photograph. It might only subtend a small angle in the sky, about 3 or 4 arc seconds, but it's 11,000 light years away. And the whole dome, the whole bubble is about 7 light years across. When you start thinking about the scale of these things, I think it's truly amazing. It's again a difficult one to process because, of course, you have this bright star in the bottom of the frame and the one in the bubble itself. And I don't think the one shown in the bubble is actually the one causing the bubble to expand. I think that's probably buried in there somewhere and we can't really see it. Lovely thing anyway, I think. Now, this is a region called Sharpless SH286 in Vulpecula. It's obviously similar to the Pillars of Creation in the Eagle Nebula, but these elephant trunks of gas, as they're called, are all over the place. John showed a smashing picture of one taken in the Pelican Nebula some couple of months back. This main trunk of gas here is about 10 light years long and about 1 light year in diameter. So again, the scale of these things is truly colossal. Although it looks dense to us, apparently it would actually be a better vacuum than you could produce in a laboratory here on Earth. So it just looks dense to us because it's so far away and we've seen so much of it. Again, oh, sorry, I just clicked the wrong. Sorry, back to that. We're looking at a very small region of a very large area in the sky, and it's one of these things where the longer focal length telescopes like C11 you can sort of see detail in these things. I think it's rather wonderful you can do that. I'm currently working on another one in. It's been so long since I was close to the Iris Nebula in Cepheus, but I've only managed to get the hydrogen alpha and the oxygen data yet. And so far in July and August, I've only had 12 hours of data for all that. I need a lot more. And the reason is, of course, the British skies are so bad, particularly this time of year. I just can't finish this subject off. So that was probably in the 15 minutes, but now back to George in the studio.
Okay, well, firstly, thanks, Mark. Really amazing images. I did like those. I noticed that, particularly when I started out imaging, that, you know, typical images had about 5 minutes or, you know, maybe 30 minutes for a faint object. And now, of course, we're looking at 7 or 8 hours total imaging time. That just shows you how far we've come along. And of course, getting magnitude 20 is considered, you know, yesterday's problem. Looks like Tony's turned into a werewolf. But putting that aside, anyone, any questions? Steve? Steve K, have you got a question?
I don't think so. No, is my hand still up? Sorry.
Yeah, oh, it's all right.
Yeah, that was from the last question. Sorry.
Okay, Chris.
I'll put it down.
Chris H.
Okay, thanks. Yeah, thanks, Mark. That was a really nice talk and some lovely images. The question I had is, I noticed in that last one, although your image was taken using a C11, you had diffraction spikes on the stars. Could you account for that?
Yes, I cheated. I actually have seen these diffraction spikes, these lovely diffraction spikes on some bits of software, and I decided to buy one. Now, when I had the 8-inch RC, the Rishi Chrétien, that doesn't have a corrector plate, therefore there's nowhere to put the secondary. They actually have a spider in the top, and it used to produce the lovely real diffraction spikes, and I rather miss those. It's a strange thing. It's an interference. It's an artifact in the picture. It shouldn't be there.
I know.
But it looks good.
Yeah,
but those are cheat.
I certainly think it helped the image. Actually, it made it look quite dynamic. But I just thought when the panel said C11, I thought, hang on a minute.
Yeah, good. Also, you'll notice that it was very adventurously processed. So you could actually say that my sharpness should be less sharp. Well, I thought it was funny.
If you wanted to, yes. Okay, thanks.
Mark, I noticed in a few of the galaxy images that there were an awful lot of what I call the tiddlers, these very small, very faint galaxies.
Oh, yeah.
Have you ever tried trying to identify what's actually in the image?
Yes, I have, and it can be really difficult. It was recently, I don't know if John's got in the gallery at all, but John had been photographing Jones 1 and came up with a faint galaxy in the picture, and he said, "Oh, you know, can you identify this?" And I spent ages going through catalogues and actually came out with the number, which was like a Brazilian telephone address. The number, I mean, it was just no popular name or anything. And well, astonishingly, when I went through the catalogues, there didn't seem to be a spectra for this faint galaxy. And of course, the thought occurs to me, if you haven't got a spectrum, you don't know the distance of them. So yeah, occasionally I track them down, but it's going to be a lot of work for little benefit.
Yeah, I'm always amazed at how faint they turn out to be where they've been measured. So Mag 18 and 19, people just yawn at now, whereas, you know, X years ago, it would have been a staggering thing to have.
Yes, I used to do things on film, but I couldn't possibly go back to that now. It would be useless.
Yeah, your expectations go up, but that's good. So once again, if we can thank Mark in the usual way or electronically.
No, top ground. Thank you.
Okay, thank you. What I think we can do now, I'll carry on recording and I'll put the recording up on the Newbury Astronomy Society webpage. Sorry,
George.
Channel. Yes, Steve.
Yeah, just very quickly. I've got some. There's only 3, I think, Perseid images. If anybody wants to see them. Hate to slow things down.
Okay.
Yes, please, Steve.
Oh, Pauline, especially for you, Pauline. Hang on a second.
Thank you, darling.
Can you? I don't know if this. Let's see if I can get this working.
That's this technology.
Well, I'm doing this on my iPad, so this is. I've got to find the right folder. Okay. Can anybody see that?
Yep.
Surreal.
Okay, so Perseid is, well, you can see it. It's on the Cygnus Rift. That's with a 6D. I didn't see many Perseids. I don't know if anybody else had more luck. I was at Cath's in Cath's Garden with Richard and Nikki. So you can see it's green as the ionization trail. Now I'm going to try something a bit different. Now, will this work? It won't work. This is actually a GIF. I used an A7S, and if it was working, let's try tapping it, you'd see a nice green ionization trail. Okay, what's the next one? And there's a Star Trails picture. Cath's house is on the left.
Fantastic, Steve.
Yeah, well, the peak night of the Perseids, there was a huge lightning storm actually over sort of Midlands, and if you look at the bottom, you can see the distant lightning, and there is actually a Perseid there. It's just below Polaris. That is a Perseid. It's going in the right direction towards the right of Polaris. That's a satellite flare, and you can see there's an aircraft or something going across the middle. Now, just 2 quick non-Perseid pictures. I have a new toy which I had a play with in Cath's Garden, which is that. So it's a 14-inch Dobsonian, which I'm very, very pleased with. And I was particularly pleased in Cath's Garden because I was able to use a go-to unit with it, which was absolutely fantastic at finding images. I call this the SMSA go-to unit. I've got an image of it here. Just go next one. There it is on the left. SMSA stands for Show Me Something Awesome, and I recommend one of these. They're absolutely fantastic. You just say show me something awesome, and it finds the object and tracks it and tells you all about it as well. So if you can get one, I recommend them. I think that's the SMSA's telescope on the right hand side. So he had to make do with a smaller telescope at Cath's. Anyway, that's it. Back to the main meeting.
Thanks, Steve. Brilliant.
Okay.
Steve, the Star Trails, was that
Yes.
a single exposure or was it a put together one?
Many exposures with a 60, and I think that was a 14mm lens. It was a really wide angle, so it's a little bit distorted.
Okay, thanks for that. Okay, what I'd like to do now is if we can open the meeting up. Yes, sorry, we should thank Steve, in either the traditional way or the electronic way. And we would expect to see some brilliant planetary images taken with that Dobsonian as well.
Yeah, definitely. Yes, I mean, I haven't used. We had a look at Mars and Jupiter and Saturn when we were out, but I felt very guilty looking at Martin's fantastic images. I'm a bit of a slacker, I'm afraid. I will get out there, I promise. But not with a monochrome camera. I'll stick to a color, I'm afraid.
Yeah, you should. I'll be looking for them, Steve, on Facebook.
Oh, pressure.
No pressure.
George, would you like me to show you a little gadget that I've made over the last couple of days?
A little what?
So
Little
can you
gadget.
say again, Steve?
I made a little adapter for my DSLR as for taking astronomical pictures, and I had a bit of time to spare and some bits of wood, and I just knocked up a little aid for taking astronomical pictures.
Okay, but I'm going to limit you to a few minutes.
Go for it, Steve.
I think you're muted, Steve.
Yeah, need to unmute yourself, Steve.
Can you hear me now?
Yes.
Oh, good. Right.
Yeah, near you now.
Yeah. So this was one of my first attempts to take an astronomical picture with the DSLR that I've had for a long time. And of course, it's Comet F3. And I jumped in the car, went up to Greenham Common, set up by the side of the road, and tried to take some pictures. And this particular one was using my long range lens, whatever it's called, the zoom lens, and an enhancement, electronic enhancement built into the camera, a bit like a Barlow. I took this picture, but then the comet moved, or I moved the camera out of the field of view, and I couldn't get back in again. So I decided I needed to do something about that for the future. So I'm not moving now. Oh, there we go. So this is the camera I use. That's the short lens. I was using the other lens. And on the back here is a little button you press, and you can increase the magnification by 1.4 or 2 times. So what I decided to do is to mount it on my PST tripod, which I'm not using at the moment because there's nothing to look at. So I knocked up a piece of wood, and these 2 screws on here would fit into the mounting here on these 2 holes. So I can just bolt a platform onto that tripod. Then I attached to that a finder shoe, which I bought from online. And on the other side, I fitted a piece of kit here that it came with an old telescope that was given to me for the society, and it's been hanging about in my drawer for about 15 years, and I suddenly found a use for it. So I got a piece of thread, the UNC thread, bought some nuts, and this is one I had already, so there's a nut to fit it to lock it. So I then bolted those together onto the table, and it's all ready then to go onto the assembly. So I've got my finder off my refractor on there, the DSLR on there, and on the alt-azimuth stand. So I can now drive it more accurately when I'm out in the field, and also see exactly where I'm pointing. So I haven't had a clear light yet to try it, but it lined up okay on a distant chimney pot. So it all seems to work at the moment. It's just a case of actually going in and do something with it. There it is from the other side. And that's it. So
Excellent. Well done, Steve.
I'm trying to finish this now. Stop share. Right.
Yay.
So just to occupy a bit of time for the last 3 or 4 days.
It looks a really nice and practical thing, because trying to get DSLR things to image actually on the screen is quite difficult.
Well, that's right. And it's very difficult to move it on a photographic tripod, because you've just got the little twist and move operation on there, which was difficult. So I think that's going to make it a little bit easier. I can do a bit more photography with the SLR.
Yeah.
So there we are.
Good. And will you put that in the newsletter or the beginners thing?
I can do. I'm writing the October one at the moment.
Right.
But I was thinking about what the main thing I want to do is do some photographs of Jupiter and Saturn as they approach each other for the conjunction in December, the 23rd of December, when they're closest. So I just wanted to get a series of pictures so that I can show how they gradually got closer together over the next 3 months.
Okay. Yeah. No, it sounds good, and hopefully it might encourage a few others to have a go.
Yeah. And hopefully we'll be able to actually see the 2 planets in the view of a small telescope, in the field of view.
Yeah.
Oh, yeah. Now that would be special.
Martin, I wondered if we could bring you back in, and I'll kick off with what I'll call a general question. That is, do you find much difference between amateur astronomers in the US compared to those in the UK?
Glad you asked that. You're recording this, right?
Oh.
That's fine. I'm just.
Yeah.
That's very sweet of you to say, and it was. I mean, even then, and I still today I don't. Maybe it's my dad's teaching or something. I don't know, but I always like helping people get into the subject and at any level and make it accessible to anybody. It's so important not to have any barriers to getting in. And yes, we had. I mean, that was. I think it was quite. When I look back at some things, it was a unique time because we all became such good friends.
Yes.
Spend a lot of time with each other and you know, maintain friendships over the decades. Even though we don't see each other, it's like we can contact each other 10 years later and go, just start up again.
Thank you. It's wonderful.
Brilliant.
Wonderful to see you, though.
Yeah.
Well, just thinking.
Actually, I can remember the exact moment and what I was doing. We were observing the moon with you, and I thought, yes, I can do this. And
Yep.
that was the moment when I made my decision where I was going to go. So
Good.
thank you.
Fantastic.
Yeah, Martin, do you remember that little observatory at Bradfield?
Oh,
Went over there with Tim.
Yep.
I think it's fallen into disuse now. George knows about that, probably. You know about that little observatory at Bradfield? They had a sort of a refractor in there.
Yeah, I was asked to go up there and give a little chat and ask about the observatory, and I was just getting blank looks. So I think it may still physically be there, but nobody's really used
So
it.
I have a story there. So I have a story here, and I'm hoping nobody shoots me down. But it was ever since I left. So they had an 8-inch refractor. And ever since I left and came to the US, I thought, whatever happened to that telescope? Whatever happened to that telescope? And I would ask myself. And I thought, I should find out. And I never did. And one year, and I think it was about 5 years ago, I said, you know, I'm going to find out what happened. So I wrote a letter. See if I can find a picture. I wrote a letter to the college. This is best done by pictures, by the way. I wrote a letter to the college, and they sent back a photograph of the telescope. And it was a 16-inch Meade. And I went, that's not the telescope. What the heck happened to the real one? Not the real one, but because we spent hours using that telescope. And so they sent back a photo, and they said, well, we're clearing out a maintenance yard, and we found a wooden box. Maybe this is it. I'm going to show you the photo.
Oh.
Yeah. Oh.
I think I recognise the drive.
Yes, it's clock drive.
Yeah. I should have dug out some photographs because I got pictures of that observatory. In it.
Oh, do you, Jeff? Because I would love, you'll realize why in a minute, but I would absolutely love, I've been looking for photos and I can't find any.
Oh, I've got loads, but they're on my other computer, which is shut down.
Yeah.
Probably, I don't know how long we're going to stay on now, so it's probably...
Right. Anyway, so I look at the state of this. I mean, it had been in this maintenance yard, and they said, I said, well, is there any glass in the end on the left? And I just waited for a day going, oh, is there anything in there? And they said, yeah, there's something there. I went, oh, it's the lens. Okay, so it's, all there are 2 pieces of tube, and that's it. And so I said, I mean, I was just devastated. I thought that is a terrible way to go. You know, what can be done? And they said, they wrote back and they said, well, we're cleaning out the maintenance shed. You'd better let us know if you're interested, because we're going to throw it out. And I went, you are kidding me. I'll probably regret this, but I wrote back and I said, yeah, I'm interested. I'm coming over to the UK in 3 weeks. What do I do? And they said, well, come and have a look, and if you can cart it away and make something of it, maybe you could do that. So I flew into Heathrow, rented a vehicle that was long enough, and I I put the pieces of the telescope in the back of the car, you won't believe this, and drove away. And it was in a state, and I thought, what am I going to do with this? So my thought was, well, I have to refurbish it. It's like nobody else has picked up on it. I've got to find out. I mean, I love this telescope, right? I grew up on this telescope. I got to find out a way to refurbish it. And so I started a process of learning how to refurbish an old telescope. And I wrote back to the college and I said, where's the mount? And they said, we don't know. It's gone. Now the mount actually has a critical piece that connects those 2 pieces of tube together. So essentially I have an 8-inch lens and a piece of brass, and you can't do anything with it. A year later, the other part was, how do I get this here so I can work on it? So I found Moonraker telescopes, and I drove over to him, and he arranged to have it shipped at rather great expense. I sometimes chill when I think of how much it cost to ship over. And then I thought, then a year later, I got an email saying, oh, guess what we found? We found the mount. And he said, what do you want to do? And I said, well, I can't really afford it, but I can't leave it either. It cost about $5,000 to get it shipped. And Moonraker did it all. It weighs a ton, and it's now sitting not very far from where I'm sitting now. So to show you a little bit, this is a talk in itself, so maybe another day we could do it, but I'm going to show you what the tube looks like today. Remember what it looked like in that thing. I'm trying to find the right. Okay. So this is the upper tube today.
Whoa.
Yeah. Beautiful.
And it's
Incredible.
it's incredible. And so and this is probably a year and a half of work. Just not a year and a half solid, but just gradually learning how to polish and not do any damage.
Have we got another 10 minutes? Because I was trying to dig out the photos from my other PC. Have we got another 10 minutes, George?
Yeah.
I don't.
Yeah, there's no problem. There's no.
I'll dash off and see if I can.
Oh, it'd be great. Anyway, so obviously, and I told my wife, God bless her, just says, go for it. Do what you need to do. So it's been very supportive. And so my story is, this is my retirement project. I haven't retired yet, but maybe I should. I can get it finished. And then I'll tell you my, I mean, ultimately and eventually, my feeling is this telescope should end up back in the public area somewhere, somehow. I would dearly love for it to come back to Newbury or that area. If somebody has a plot of land and can build an observatory, we'll put it in there. It will not be cheap. Not cheap from my perspective. It just won't be cheap to do. But anyway, it's in safekeeping. I've got the lens on the shelf here, and it's just not being touched. It's a bit like the BAA Winchester tapes, right? It's like, I've got to save it. So anyway, that has been rescued. It was literally, I think, about 3 days away from being dumped when I sent my email saying what happened to that telescope. And I cannot believe in the 20 years that I thought of sending that email that I sent it 3 or 4 days before they trashed it. I can't believe my luck. Something was telling me, email now. And I just find that whole idea kind of makes the hair stand up on the back of my neck. So anyway.
Who made the lens, Martin?
It's a Cook lens.
Sorry, a Cook.
There was a debate, and there's a little bit of story in the BAA Journal around here because John Wrigley at Reading Astronomy Club knew a lot about this telescope and was part of the group that initially got share of it with Bradfield College. And there was a talk that it was a Clark lens. And so I took a photo of it, and I think I sent it to Francisco Diego at UCL, which is my old college, because they have an 8-inch Cook. And he said, yeah, the manufacturing of that looks like a Cook lens.
Yeah. Right.
There was another story as well from Frank Gear, who was in Reading. Frank and I chatted a bit, and he said, you know, there's a story that might have been the telescope that is it William Huggins used for spectroscopy.
Really? Wow.
It's not.
No.
There's a historian. There's a historian in California, Barbara Becker, who is an expert on William Huggins, and she said, no, that's not a telescope. The lens is in Cincinnati that William Huggins used.
I think given the history, I'm not surprised when I asked.
I have found a load of pictures.
Don't know anything about it.
Sorry, say again.
Me? Oh yeah, I found a load of pictures now.
Oh wow!
Want me to?
Yeah, go for it.
Yeah, go for it.
Okay, I'll see what I can find then.
It's all
Da, 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 da. Where are we?
great because I've been looking for this stuff.
No, I can't see where my.
Because my only photographs are old ones that I took with an old Polaroid, and I have the photo here.
Oh,
It was in a state back then.
Hang on, hang on.
While you're looking, Jeff, let me.
Yeah.
You okay? Go ahead. Go ahead.
Sharon.
Okay. Here we go. On here. Right. That is the telescope.
We
I
can't see it, Jeff.
We can't
What?
see it.
We
Oh.
can't see them, Jeff.
Stop sharing and then reshare.
Yeah,
Right.
it was just
Now
during the.
reshare the screen.
Ah, right. See anything?
Yeah.
Oh my,
Yay!
Yeah, fabulous. Yeah.
oh my goodness!
I just wonder if I can get any more. Oh, look who's out in the bottom right-hand corner.
Ah! My goodness!
That's Tim
A
Abernethy
little
and
Martin.
little Martin Radcliffe. Oh, this is sorry. I just did a whole load of pictures. These. Oh, there he is. Hang on.
Oh my goodness! Yeah, Winchester.
Yeah.
What?
I can email all these to you.
Oh, that would be brilliant. I remember those shots.
Yeah.
Of there's John Trott and
Everybody there.
Amazing. Yeah.
used to go to the Eclipse pub. There's
Yeah.
Yeah.
Who's this in the background here with the black hair? There?
no idea with the
That's a while ago. Oh, there's little, what's his name? Wrigley.
John Wrigley, Jim Bett.
There's Don. Don Topley.
Is that Ron Proctor? Was that on the right?
Yes, that's right. Yeah, him.
And Alfred.
I forget the names of the others
There's
now.
Alfred.
Frank Deere. Frank Deere.
There's more. Hang on. I've got a few.
What you two
I
go
just
with
grabbed a
them?
load of. Oh, there we are.
Good
Oh,
grief.
A very
Whoa.
young Martin again.
Brilliant.
Oh, dear.
Amazing.
Winchester, this was. Oh, that's the Bradfield Observatory.
Yes.
Oh, that's when I took the family over. That's that clock drive.
Wow.
Oh yeah. Yep.
Oh.
Oh my goodness.
My late wife. There's my kids when they're about 50 years ago.
there's an AE.
Oh, so hold that picture, Jeff.
Yeah.
Hold that. There you go.
The focus.
Oh my God.
Well, I'm blowed. Yeah.
That's
Yeah.
it. Right there.
History in the making.
It really is. Right.
This little lad here had his 49th birthday a couple of days ago.
Wow.
And
Good grief.
she is the grandmother of my great grandson or great grandchildren. I think there might be a couple more. Oh yeah.
Oh my God.
Tim
Wow.
Abernethy, Don Topley, Martin, and this I forget what his name was. He was one who came in the car with us to Reading.
That's right. I can't remember his name either.
I can't know, but
That was yeah. I was going to say that was the trip to Hatfield's place.
yeah. Did you go to that?
Yes.
Yeah. There he is in the corner, Commander Hatfield.
Very memorable.
His solar dioscope,
Is
or whatever you called it. There he is. There's Muriel and
Wow.
Glee and the little dog. And that was it. Oh, that was just my picture of the comet.
Oh, nice.
George has seen that already.
Yeah. Oh,
Okay.
they're brilliant, Jeff. They're absolutely brilliant.
Yeah. So let me have your email address sometime.
Yep.
And I will forward you. There might be a few more I can find as well to
Because I think you're on Facebook, right?
What?
Brilliant.
Are you on Facebook, or how do I get?
I am, yes.
I'll have to hunt that down, and I'll send you an email via Messenger or something.
Okay.
That was thrilling. I mean, I've just imagined that telescope, and I've never seen anybody with a picture of it until
how we used to was.
how we used to. That's priceless.
Indeed. Yeah.
Amazing.
Makes you feel old.
Yeah.
There you go.
It's going to be a
Thanks,
bit
Jeff.
Anyway.
One of my thoughts in trying to refurbish the telescope is to keep this the same. Don't clean this up, because this is how we used it. But if I did clean it up, it'd be bright brass, because this is all solid brass.
Uh-huh.
And it's really heavy. I mean,
while I was out of the room, I didn't realise you'd actually rescued the telescope and taken it home.
oh no! So you missed that part of the story. You'll have to watch the video.
Yeah, okay.
Oh, yeah.
But in a nutshell, I'd emailed the college saying what happened to it, and they sent
I saw that bit, and they sent you a picture, told you about the great big one they had.
Well, I ended up getting it and spending lots of money that I probably shouldn't have, getting it shipped over so I could clean it up.
Right. Well, I'll see if I can find a few more detailed pictures of that.
Brilliant. That would be, yeah, any detailed pictures of that telescope are priceless. Yeah.
Oh, I'm glad I could help.
Yeah, that's fantastic. Wow.
Fantastic story.
Well, just think we got
COVID.
COVID.
I have to go now, but it's been fascinating listening to this. Thank
Right.
you.
Nice to meet you, Jane.
Just think, if it wasn't for COVID, we wouldn't be having this meeting.
No, it's really got silver linings in many ways. And oh, I just saw Nick Fleet pop up in the bottom right-hand corner. I wanted to say hello. Good to see you. And I'm sure there are lots of other people.
You too.
Thanks. You have not changed one iota, by the way. It's like, really? How do you do that?
So when you've refurbished it and got it working,
Yeah.
you must take an image of Mars through it.
Oh, yeah. I mean, that's very high on my list.
Yeah. Yeah.
And I have, I mean, somewhere around here, I did my astronomy practical observations with
That was quite an amazing piece of engineering.
Yes.
Did you have that as well?
Yes.
You had that.
That was one of the first pieces I